This conference will now be recorded.
Hello everyone, good evening. Am I audible,
Good evening, sir.
guys?
Yeah,
Yes,
you're
sir.
audible.
Hello, everyone. Good evening.
All right, let's wait for a couple of minutes, then we'll start. All right, let me share my screen. A moment. Okay, let me know once my screen is visible.
Yes, sir.
Yes, it's visible.
All right, so today we are going to start with SQL Server development or SQL Server programming. So, let's start with this topic. What is Transact SQL? So, any idea what is Transact SQL or T-SQL? Anyone having any
So the
idea about
SQL that
Transact
is
SQL?
SQL that was invented by Microsoft.
Hmm. No, SQL was invented or developed by IBM, okay, and it was adopted by Microsoft.
Yes,
And
sir. The SQL
Microsoft,
that was adopted by Microsoft.
so it was adopted by Microsoft, and they did some modification, and they named
Uncle.
it T-SQL or Transact SQL, okay. And the transaction SQL programming language is applicable on relational database, which is Microsoft SQL Server, okay. Now we'll learn about schema, we'll learn about different objects, we'll learn about different type of statements. Then we'll see how the basic statement or select statement works. We'll work with different type of data or different data types. And then we'll see a special character that is called as null. Okay. So that's the basic introduction of T-SQL, and then we'll proceed from there. Okay. So what is Transact SQL? So Transact SQL, the full form is Transact Structured Query Language. In short, it called as SQL. So SQL is developed by IBM in 1970s, as I said, and it was then standardized by ANSI and ISO. Okay, so IBM did the patent of SQL programming language, which is now widely used in the industry. Okay, now Microsoft has adopted the SQL language, okay, and did their own implementation on top of it, and they named it Transact SQL or T-SQL. Okay, So T-SQL is basically a query language for SQL Server and Azure SQL Database. Any idea what is Azure SQL Database or what is Azure? Anyone having any idea?
Yeah, that's the
Sir, it is a cloud
Microsoft.
platform.
Yeah, right.
Cloud
So
platform.
yeah, so basically the same thing that we are learning here. The difference is only in the platform, or in simple words, the difference is where the server belongs. So currently what we are learning, the server belongs to us, but Azure, the server belongs to Microsoft. Okay. Anyway, so SQL is a declarative language. Okay. Now, in other words, declarative language means SQL is a high level language. Okay. In this language, we are not going to, you know, uh, tell each and every step what the programming needs to do. All right. So instead of that, we just need to tell to SQL Server that we want to do this, and it will perform the same thing. All right. So anyone is having questions till now? So let me reiterate one more time, because I want to go through this slide one more time because it's very important to understand. Okay. So here we are learning SQL. Okay. So the full form of SQL is structured query language, and structured query language is basically developed by IBM in 1970, and then it's adapted by Microsoft, and they did their implementation on top of it. On top of SQL, they added some additional features, and they named T-SQL or Transact SQL. Okay, and SQL is a high-level language. We need to just declare something, or we need to just tell or instruct what to do. I mean, we can just tell SQL Server that I want this. How to do this? That will be taken care by SQL Server. Let's say we need to tell SQL that I want to see the data, and how to get the data, where the data belongs, that will be taken care by SQL Server. We just need to give the instruction. Okay. All right. Coming to next about relational database. Now, what is relational database? First, we need to understand about table. So when we see our database server, so this is our server. Okay. This is our server, or we call it instance, right? So under instance, we have what? We have some databases, right? So the databases are these. These are the databases, right? Under the database, we have what? We have tables. Okay. Now, whatever data we store under these tables. Okay. Now, when we say we are saving data, that means we are saving data in the table. So within table, we store our data. Okay. All right. Now we need to understand the structure of a table. So a table typically consists with columns and rows. Okay. Now what is a column? Column is this: customer ID, first name, last name. This is column. And what is row? This is row. So 1 Dan Drayton, 2 Aisha Witt, 3 Rosie Reeves. So this is row. Okay. And customer is the table name. So I have a table, and in this table I have some column names and I have some respective rows. Now let's say I told you to create a table, the table name is, let's say, create a table for students. All right. So what would be the columns for the table students?
Student name,
What
Student
would be the
ID,
column
student
name?
ID,
All
Name,
right.
roll
Student
So
number.
ID.
let's go one by one. Okay. So I want to save the details of students. Okay. So I need to store the student information. Now the respective columns would be student ID, because we need ID for every data. Why? What is the implication of ID? That we'll discuss later. Okay. But first of all, we need ID for every information, right? So student ID is there. Next is what? Student name.
name,
Next is what? Student age.
Student mobile number.
Student contact. Next,
address,
student address. Next, anything else? That's it. Okay.
student.
Student
So, so we can keep on adding the columns depending on the requirement. Okay. So for now, let's say this is the column. Okay. So I have a table, and this table is holding all these columns. Now, what would be the rows? So I am going to insert some details for the student table, right? For the students, I need to add some details. So the details would be added as a row. Okay. So student ID is 1, name is, let's say, Raj, age is 22, contact is 12345. Okay. Address is Goa. All right. So this is a row. The entire thing is a row. And you need to understand one thing: a row is tightly bound with each other. That means to get the information, you need to get the entire row. Okay. So this one is tightly binded with this, again this, again this, again this. So the entire row is tightly bounded with each other. Okay. Now let's say the next row is 2, student ID 2. Let's say Ria. Okay. Age is 24. Mobile number 98765. She lives in. All right. So this is second row. So now what we can say is, I have two student details saved in my student table, right? And the two details are row number 1 and row number 2, right? So this is the basic structure of a table. Now this is what? This is called as column. Okay. And this is what? This is called as row. So is the understanding of row and column too clear, everyone?
So basically, Saurabh here. Basically, we can
Mhm.
say that whenever we're pulling out the data from database, it will be the whole row. We cannot pull each cell, like individual cell in a row.
We can pull individual cell in a row, but the thing you need to understand is,
Hmm.
when we talk about that, the information of a student, that means the information of a student is this.
Yes.
It cannot be like 1 Ria 24 1235 and Pune is one student information. It has to be this, or it has to be this. We cannot mix and match between rows. So the entire row is holding one information. Every row is independent and isolated with each other. 1 Raj 22 1 2 3 4 5 Goa is one information. 2 Ria 24 9 8 7 6 5 Pune is one information. So these two information are independent with each other, or this information is a related information. This information is a related information. So row, we see a data as a row basis. Is it clear?
Yes, got it.
Clear.
All right. So when we talk about this column, student ID column, so this is basically a segregation of data. Okay. When we call that student name, this is a segregation of data. So that doesn't mean a column will be holding the related information. Raj and Priya, they have nothing to do with each other. Okay. But this is a related information. So data gets stored as row basis. Okay. And data is getting segregated as column basis. So in this column, we are storing what? We are storing SID column is holding all the student IDs, nothing else. So student ID is not going to hold student name or student age or student contact or anything. It will hold only student ID. That means column is a segregation of data. So student ID will hold only the ID. Student name will hold only the name. Student age will hold only the age, right? So column is segregation of data and row is basically the actual data. All right. Now let's consider about relational database. Now what is relational database? Let's say in a database we have multiple tables, right? Let's say we have a customer table, we have a sales order table, we have a sales order detail table, we have a product table. So when we are selling something, we are selling this to whom? When we are selling a product, we are selling this product to whom? To a customer,
Yeah.
Yeah.
right? So
Yes.
a cell table holding what column? Order ID, order date, and customer ID. So this
Yes.
customer ID is what? Nothing but this customer ID. So company is holding a customer details and the sales table is holding the sales details. So when the sales table is inserting a record, order number one, order date this, and customer ID this, that means the customer ID is actually from the customer table. Yes or no?
Yes.
Is it
Yes.
clear to everyone? So we have a relation of sales table customer ID to customer table customer ID. This is a logical relation. So this is not a physical relation. Okay. So the logical relation is there with one table with another table. That means the tables are not independent with each other. The tables are related with each other. Okay. So when we say I have sold a particular product, that means I have order ID, let's say product ID and quantity. So this product ID is actually the product table's product ID, right? So this product ID is product sales order details table's product ID actually belongs to product table's product ID, right? So the tables are related with each other. So when we have a database and in the database we have multiple tables and the tables are logically related to each other, then this type of database is called as relational databases. Is it clear to everyone?
Yes, sir.
So we will learn, right, how to relate the database and extract the information.
Yeah, we are going to learn obviously, but is this concept clear to everyone?
Yes.
Now, the thing is, it's not necessary that with one table, every other table needs to be related. Okay. It may happen that with one table, we have relation with one table, one-to-one relation. Here we have
One to one.
one-to-one relation. Here we have one-to-one relation. It could be one-to-one relation. It could be one-to-multiple relation. It could be happening that one table is independent. With this table, no one is having any relation. Okay. Let's say one table is, let's say, audit table. Okay. So we have an audit table. With this audit table, no other table is having any relation. So that could be present as well. So it's not mandatory that every table must be a participant in a relation. So it could be related to a table, it could not be related to a table. But the option is there that the tables could be related. So it's not mandatory, it's a flexibility or a feature to have. Okay. So entities are represented as relations or tables in which their attributes are represented as domains or columns. So in simple words, tables are represented as row and column. Okay. And most relational databases are normalized. Now, what is normalization? I'll come to that. And the tables are having relations with each other using primary and foreign key. Again, I'll discuss about what is primary key and what is foreign key. Okay. All right. Now coming to next, schema and object. Now, what is schema? What is object? First of all, a table name will be referred as a object name. Okay. Now let me give you an example. So this is a table name. Now the table name, if you see, the table name is human resource dot department. What is the table name here? Any idea what is the table name here? Here
Department.
department is the table name.
Yeah.
So is this is table name. And what is this?
Database
This is
name.
no, this is a schema name.
Okay. Okay.
Now the question is what is schema and what is table name, right? So human resource is a schema name, department is a table name. Now we have to understand the logical segregation, logical divide that we create within a database. So first is instance. We create an instance. Why we create an instance? To save data. In simple words, we install SQL Server to save the data, right? But we are not saving data to the instance directly. We are doing a logical segregation by creating databases, right? So there is logical segregation of level 1. So our intention was to save data. That is why we created the instance, but we are not saving the data in the instance. Instead, we have created some databases to save the data. Now, within database, are we saving the data? Within
We are
database,
saving
are
the
we
data
saving
inside
the
the
data?
table.
We
We are
save
No,
data
we
in
are
saving data
tables.
inside
In,
table, not in
yeah.
the
table.
database, right? So
Yeah.
Yeah.
again, another logical segregation. We have table. So we are not saving the data in database. We are saving the data in table. So logical segregation of level 2. Now, here we have a huge gap between these two logical segregations. Okay, so as per the experience, it has been seen that this segregation is not enough to manage the data. That is why we are putting another layer of segregation. This is called as schema. Okay, so this is basically another layer of segregation. This is called as schema. So logical segregation of level 2 is this, and logical segregation of level 3 is this. First is instance, then database, then schema, then table. That means when we need to access a particular table, we need to navigate to that location. How to navigate? Instance name dot database name dot schema name dot table name. So if we give the full path, then only we can navigate, right? So this is called as full qualified name or fully qualified. That means this name we are giving the full location. We are giving the instance. So for this case, if we want to go and search for this table, so what would be the details? Instance name is Hermes or my laptop slash Hermes. What is the database name? AdventureWorks. Then what is the schema name? Person. And what is the table name? Yes.
Address.
Instance name, database name, person is the schema name, address is the table name. So this is the fully qualified name for the table address. Fully
Excuse me, sir.
qualified. Yeah,
Sir,
go ahead.
can we say schema name as a folder?
Uh, so yeah, it's doing the same purpose as folder. Okay, what folder
Mm,
does?
yes.
Folder do a logical segregation, right? So you have 100 text files. You want to logically segregate them. 10 files in one folder, 10 files in another folder, 10 files in another folder, right? Like this. All right. So
Yes, sir.
schema
Yes,
name
sir.
is doing the same logical segregation. So as you can see in the table
Oh,
list, under DBO schema, we have 3 tables. Under human resource schema, we have 5 tables. Under person schema, we have couple of tables, right? Under production
yes, sir.
schema, we have couple of tables, right? Under purchasing schema, we
Yes,
have
sir.
couple of tables. So under sales schema, we have couple of tables. So by watching this, what you can understand is it's basically logically segregating the purpose of the tables. So department table,
Okay,
employee
sir.
table, employee department history table, employee pay history table, job candidate table, shift table. So these tables are part of human resource. So human resource department is managing this table, right? There is a
Okay,
schema
sir.
called person. So person is a logical segregation for these tables. Production. So here you have all the tables related to the production. Here you have all the tables related to purchasing. Here you have all the table details related to sales, right? So there is a logical segregation. So if we go to the slide, fully qualified name is what? Server name dot database name dot schema name dot object name. Here object name is table name. All right. So
Yes, sir. Got it.
within database context, best practice is to include schema name. That means we don't have to mention all these details when we mention table name. All right. The best practice is to only mention schema name. Why? Why we can skip the server name and database name? The reason is, as I told you guys in the previous class, when we are connecting to a database, we are connecting to the instance and a database. So we already know that what is my instance name and what is my database name. Likewise, let's say in this session, I know what is the instance name and what is my connected database name. So within a database, if I want to search for a table, I need to give which information? Within a database, if I have connected till this,
Then only schema
so
and table name.
this is a session or this is a connection, right? So in this connection, I have connected to a database. The database name is demo, right? So how I can connect to a database? First, I need to connect to the instance. Then let me show you guys. I have to first connect to the instance, right? Then I have to open a new query or a connection. Then I need to give the database name, right? So here I have made the connection till this, right? Now, as I have come till this point, now rest is what? Schema name and table name. So that is why when we are searching a table, the best practice is to give the schema name and table name. That's it. So we need to give schema name and table name. That will be enough to search a table.
Sorry, sir, Omkar here.
Yeah,
Hello.
yeah, guys.
Sometimes we forget the name of the database and instance name. How can we find the schema name only? Oh, sorry, if you forget the schema name, how can we find that?
If you
If
forget
you
the
want to,
schema name, there is no way you can find it. You have
oh,
created the tables. You are the owner of the table. You are the owner of the
yeah,
schema. If you forget the schema name, then who will remember the schema name? Schema name.
okay,
So you are the owner, right? So if I
yes,
tell you that you are the owner of yourself, and you tell like I forget my name, who else will forget your name? I mean, who else will
no,
remember your name? You
no
are
one.
the owner of yourself. If you tell like I forget that my details, then who will remember the details? So you have created the table, you are creating the database, you are creating the entire structure. If you forget the structure itself, then uh, it's not a problem. Uh, it's something which we must know. Okay.
Okay,
Anyway,
sir. Thank you.
so let's understand the structure virtually. So here is one schema. If you see the box, this schema is called as sales. Let's have another schema. This schema is called as production. So within this schema, we can have a table called order or customer, order and customer. In this schema, again, we can have a table called product and order. Now, one thing to notice is we have a table called order in both of the schema. So how we can identify that the order table is belongs to sales schema or production schema? To identify that, we need to mention the schema name. So when we want to refer this order table, we will write sales.order. When we want to refer this order table, we'll write production.order. That means schema name dot table name. This is very important to mention when we are mentioning a table name. Is it clear? Is
Yes,
it
sir.
clear to everyone? All right.
Yes, sir.
Yeah, clear.
So let's go through these points. The full form of SQL, structured query language. Full form of ANSI, American National Standard Institute. RDBMS, Relational Database Management System. What is SQL and T-SQL and what is the difference? That we already discussed. SQL is developed by IBM and T-SQL is basically a version or a implementation of SQL with some added features, which is adopted by Microsoft. So T-SQL is a Microsoft product, SQL is a IBM product, or SQL is a IBM language, T-SQL is a Microsoft language. Okay. What is schema? That we already understand. What is fully qualified name? That we already seen. Okay. All right. So let's go to the next part. SQL statement types. Now here comes the fun part. Now we are actually going to learn about the different type of commands that is present in SQL Server programming language. Okay. What are these commands? So these commands are categorized into these three parts. Okay. First is DML or data manipulation language. That means with this type of commands, we can do data manipulation. What are these commands? Select, insert, update, and delete. So using select, we can do what? We can see the data. Using insert, we can do what? We can insert the data. Using update, we can do update of data. Using delete, we can delete the data. So from where? From table. Okay. Next is DDL. What is DDL? Data definition language. So what is data? So in SQL terms, what is data? A data is basically the row. The row is the data, right?
Yes.
Yes, sir.
So when we are defining the data means what would be the table structure? What would be the column types? What would be the column name? What would be the table name? So when we are defining the data, or when we are telling how the data will look like, or how the structure of the data will look like, then what is coming to our mind? So to define that, we need to define what would be the table name, what would be the column names, how many columns would be there, what would be the type of the columns, right? So this is an integer type column because it's holding integer values 1, 2, 3, 4, 5. This is a character type column. It is holding characters A, B, C, D. It's a integer type data. It's holding number values 22, 23, 24. This is contact number values. This is string type or character type. It's holding A to Z values, right? So the commands that will help you to define the table structure, that is called as data definition language. So within data definition language, we have commands like create, alter, and drop. So create, alter, and drop means creating table, altering table, and dropping table. So when we create table, that will help us to create a table. When we use alter table, that will help us to alter the structure or change the structure of the table. So point to understand, changing the structure of a table and changing the data of a table is totally two different things. So when we say I want to change the column name of s underscore contact, I, I want to change the column name from s underscore contact to s underscore mobile. So this is not changing the data. This is changing the table structure.
So,
And when we
Devabhat,
say, yeah,
sorry to interrupt. Actually, one basic question, okay, I'm very much confused. How are these tables created? Like, who creates this, or because we are
so
just
we are
learning how
going to,
to access the
yeah,
data,
yeah.
right?
So we are going
We
to
will create this
see
table.
how we are going to see how we can create table. We are going to see how we can insert data into table. But first we need to understand the logical, first we need to come to a logical conclusion. Implementation will come next to that. Okay, first is
Okay.
understanding, then the implementation. Implementation will take 1 minute of time, that's it. But
Okay.
understanding the thing is more important. Okay, so anyway, we are going to learn how to create table, how to alter table, everything. Each and every step we are going to implement. All right, so when we say changing the column name, that is the part of altering table structure or changing the table structure. That is not changing the table data. When I say I want to change Raj address to from Goa to Delhi, so this is change of data. This is change of data definition or change of data structure. Okay, so this alter table means altering the table structure. Dropping means dropping of the table. Okay, so create table, alter table, and drop table is a part of data definition language. The next part is data control language. So as we learned yesterday, we need to give permission to the users who can access the data or who cannot access the data, right? Now the command to do that is grant, revoke, and deny. That means to control who can access the data and who cannot access the data. So the control of the data is basically done by using these commands: grant, revoke, and deny. Okay, so we have basically these three type of commands in SQL.
Debabrata,
Yeah,
deleting is for the deleting the data in the table, right?
yes. Delete
And
means
dropping
deleting the data. Drop means dropping the table.
table. Okay, right.
Okay, all right. So let's see the first SQL command. Okay, mm, let's let's understand the first SQL command. Let me connect to Adventure Works database. All right. Now this is the command. Now let's understand few things. If you want to comment line something, do you know what is comment line? Comment line means I want to write something, but I want this thing excluded from the programming. That means I I need that the statement should be there, but the statement will not participate in the program execution. So to do that, we need to give double dashed. If I give double dashed in front of a string or in front of a line, this line will act as a documenting line. So this line will not act as a programming. This line will not be a part of the programming. Let's say I have written this: understanding select operation in details. So this is a header that I have written to understand the topic, right? So this is not a part of the programming. That is why I have
You
given double dashed in. That means this is a normal English statement. This is not a
Oh,
programming
yes.
language. All right. So I have commented out this line. So this line is not part of the program. In the same way, I have another comment line this, I have another comment line this, this. So why I've given this? I've given this to document this program or document this statement. Okay. So what is the statement? What is the actual statement? The actual statement is this. So let me show you the actual statement. This is the actual statement. If I remove the comment lines, that will give you the actual statement. I've just given the comment line for my understanding or for your understanding. Now I have
you
removed
mean
all the comment
this is
lines. This is just for your understanding purpose or documenting purpose. So these lines will not participate in the program execution. Only these lines will participate in the program execution. Now how we can tell SQL Server that don't include these lines in program execution? By mentioning double dashed in the beginning. So see, double dashed in the beginning. So rest part would be considered as a comment line. All right. So this is our first programming language or first query. All right. So as I said, to see the data, we need to use select command, right? We already know that data manipulation language, to see the data we need to use select command, right? So select is there. Now we need to give star. What is the meaning of star? Star means I want to see
Calling some.
all the columns. No, star means I want to see all the columns. Okay, so I want to see all the columns of what? So I want to see all the columns from schema name dot table name. What is the schema name? Let's say I want to see all the details from person schema address table. So select star from person dot address. Okay. Now if I select this and click on execute, so this will show us all the table details. It's still executing. Now it got executed. So it will show us all the column details of person dot address table. Is it clear to everyone?
Yes.
Yes,
Yes,
clear.
sir.
All right. Now let's say I don't want to see all the tables. Oh, sorry. I don't want to see all the columns. Address ID, address line 1, address line 2, city. All the columns I don't need. I just need address ID. So instead of star, I'll give only the column names. So I want to see address ID, comma. I want to see address line 1. I want to see
Someone mic is
city.
Sir,
on.
someone mic is on.
Guys, please go on mute. Yeah. So I don't want to see all the columns. I want to see some selected columns, right? So I won't be giving star in that case. I'll just mention the column names that I want to see. So I want to see address ID. I want to see address line 1. I want to see city, and I want to see, let's say, postal code. That's it, right? That's it. So select column names separated by comma from table name, right? So let's select the command Then execute. See, only the selected columns has been shown. So postal code is basically, when in India we say pin code, right? So postal code is basically the same thing. So is it clear about this statement? Guys, please, whoever not talking, please go on
Yes.
mute.
Yes, it's clear.
Yes.
Yes, sir.
Yeah,
Sir,
clear.
so, so this is preloaded system tables, no, sir?
Sorry?
Actually, these tables, sir, these are system tables, sir.
Yeah. No, these are not system tables. These are user tables only.
Okay, okay, sir.
All right. So now let's see our previous example. So we can simply write it like this. Select address ID, address line 1, city, postal code from table name. We can write it like this as well, right? So that will also give you the same output. So now we can resemble with this command to this command, right? Now let's see the meaning here. So understanding select operation in details. First is select, statement of what we want to do, or instead of command of what we want to do. We want to do select operation, that is why we have written select. Then address ID 1, what is this? List of columns separated by comma. City, list of columns separated by comma. Postal code, list of columns separated by comma. State province ID, list of columns. As it is a last column in our list, no separator we need, so no comma. From table name, that is the data source, right? So I want to select all these columns from where? From this data source, right? Now one thing is left is where clause. Now what is this where clause? If I run this, so this is my query, right? Now let's say this is the entire data that you get from this table. Now you don't want all this information. You want only the information where city is, let's say Paris, or city is, let's say uh, let's take a funny city, Metz. Okay, so you want to see only the table details where the city is Metz. So how to do the filtration? So we need to give another command, which is where column name city is equals to Metz. Now one thing to understand, I have given single quotes to give the value. Why? Because as it's a string type, we need to give the string value under single quotes. Okay. Now, after defining the entire query, then we need to write where clause. Okay. Where column name equals operator value. So if I run this, it will show me only those information where city is equal to Metz. So we can do the same thing for other columns as well. Let's say where uh, address ID is equals to, let's say this. So as address ID is a numeric value, we don't have to give single quotes. So address ID is this, that's giving us a single row. Now the question is, why filtering with city was giving us multiple row and why filtering with address ID is giving us only one row? Can anyone tell me?
Because
City is
address
for,
ID is unique.
yeah,
Yeah.
Yes.
address ID is
Because address ID is unique throughout the table. So for every address ID, we are going to see a unique value. All right. So this is our very first SQL command. So as I told you guys, SQL programming language is case insensitive. So whether you write it in capital letter or small letter, that doesn't matter. Okay. You can write it in capital, you can write it in small, you can write it in a single line, you can write it in multiple lines. That won't matter with the program execution. Okay. All right. So we have
Devabrat, I have
learned
a
about,
question.
yeah, tell me.
Yeah, for doing any operations in SQL, right? In the tables, the before we need to know the information in the tables, right? The what are the schema name and what is the object name and what is the information under that. So how do we do
Yes.
that?
So as I said, who created the database? So when you are developing a code or you are developing a query, that means, I mean, in simple words, if you are searching something in your house, that means you know where you have placed that thing. Suppose you have a file, what you currently need, right? So you must be having the key of your house. You must be knowing in which room you have to go. You must be knowing which closet you need to open. You must be knowing which rack the file is. You must be knowing out of all the files which file you need to open to get your particular information, right? In the same way, you have created the database, you have created all the tables, so you know that what is the purpose of this table and what is the purpose of this table, what is the purpose of this table. So you must be knowing the entire structure of the database or entire structure of the tables. So if you have forgotten, let's say, that what are the columns we are having in the table, so you can simply expand the table and expand the column part. Here you can see all the column name details. Or you can do a simple thing. Instead of, if let's say you don't remember what are the column names, so you simply type select star from table name. So select star from person dot person. So I want to see this thing. Select star from person dot person. So here you can see business entity ID, person type, name style. So all the columns will be listed here if you type star, right? So you can simply type select star from table name, and once the data is presented to you, you can then do the selection. Select, let's say, person type as per your need, right?
Yeah,
so
that's
they were,
right. But here
uh,
we do not have created the we are working on the adventure works, but we have not worked
Mhm.
on this database.
So you, yeah, you need to understand the structure of the database. You need to understand that what are these tables. If let's say, if you want, if I told you that please give me the address details, so tell me which table you need to search here. You have a table
Yeah, the
called
address.
person.address, right? So
Yeah,
from the
yeah, yeah.
table name, you understand that which table you need to search. Let's say I tell you, tell me the employee details. So where you will search? Under human resource dot employee table, right? So I can directly
Correct.
tell you the table name. I can directly point you the table name with very minimal time, because I have read through the database. I have a deep knowledge of the database structure and the table structure, right? In the same
Yeah.
way, when you are writing a code, you must be analyzing the table structure of a database. So that is a task that you need to do. If
Yeah.
you
Right.
don't know the table structure, you cannot write query on the database. First, you need to
So,
understand the table structure of the database. Okay?
so one question,
Yeah.
Debabrata. See,
Yeah.
let's say we don't have the object explorer. Okay, we are inside the
Mm-hmm.
database now. Is there
Mm-hmm.
a there something like we can find out the list of all the tables and all the folders inside the database? Is there a code or query for that?
So let's say you don't have the object explorer. You only
Correct.
have the
Now,
query editor.
yes. Now, how do we?
Yeah, we
Uh,
have we have we have the respective commands as well, but that would be part of advanced section. So let me, as you asked me the question, let me tell you. So
okay.
there is a schema called information schema. Okay?
Okay.
Dot table. If you execute this, you have all the tables. Under
Okay.
AdventureWorks database, you have all the tables.
Got it.
Okay. So this is not the correct way, I would say, because
Hmm.
the we need to first set our expectations. Okay. The
Hmm.
expectation is, if you are writing code on a database, you must be knowing each and every structure of the database. That is the expectation. The expectation couldn't be like you don't know the details of a database and you are trying to get some information from the database. First, you need to know the structure of the database, then only you can extract some data from the database, right? That is the expectation.
Okay. Got it.
All right.
Okay.
So,
Thanks, Debabrata. Yeah.
yeah. So basic query examples that we have seen. All right. Now let's understand about data types. What are the different data types? So when we work with d- different type of data, then we must assign the type of data. So when we talk about a table, let's say I talk about this table. When I talk about this table, then I talk about different columns, right? So this column is holding a particular type of data. This column is holding a particular type of data. This column is holding a particular type of data. This column is holding a particular type of data. So every column is holding a particular type of data, right? So the particular type of data is defined as a data type. That means the type of data we are dealing with. Okay. So which type of data we are dealing with on a particular column. All right. So let's understand what type of data we have for numeric. Numeric means numbers, right? So in number, we can have different type of data. We can have tiny int. So for tiny int, the range is 0 to 255. Okay. We have small int. For the small int, the range is minus 196 1925 or something to plus 1924, let's say. I don't recall the exact range, but this could be an example. Okay. Now the integer range is bigger than this. Big integer range is bigger than this. Bit is basically 0 and 1. Decimal means the decimal point values. That means 10.5, 20.25. So these values comes under decimal data type. Numeric is also the same. Money is basically 10.5 or something, right? Small money is again holding the money values. So this is part of numeric or numbered, different type of number types. Next is approximate numbers. So we have float and real. So approximate numbers means 10.2554983. So this number we can approximate it to 10.95, right? So this kind of approximate numbers is having under float and real data type. Now next data type is for character type of data. So we have like char, varchar, text, nchar, nvarchar, and ntext. These are the data types for character. For holding date time information, right? So date time information, for date time information we have the data type of date time, date time, date time 2, small date time offset. So these are the data types to hold date time information. Binary information, we have binary, var binary, image, and we have some other type of data as well, like cursor, we have table type data, we have XML type data, we have geometry type data, etc. So we deal with different type of data in SQL Server. So every data have a particular type of data type. All right. So implicit conversion, explicit conversion we'll learn later. Now let's understand about null values. So let's say when I say that let's say you are filling up a form, okay, and the form is having name, age, blood group, contact, address. Contact means mobile. Okay. So name we have a star mark, that means mandatory. Age is star mark. Let's say age is not star mark, not mandatory. Mobile number is star mark, mandatory. Address is mandatory. Blood group is not mandatory. Okay. So let's say this is the form we need to fill up. So as this is mandatory, we need to fill up the form. So name is, let's say, XYZ. Age is not mandatory. All right. So for age, what we can do? Let's say for age, we can skip the value. Let's say for mobile, this is a mandatory field. We are giving a number 98303030. Okay. Address, this is mandatory. We are giving, let's say, Kolkata. Blood group is not mandatory, but still I am giving my blood group. This is optional, right? So I have given the blood group. So this case, age information, I did not provided the age information, right? So when I'll be saving the data in my table, I'll be saving XYZ. Let's say I have an ID 1, okay? Name would be XYZ. Age is, so for age, what we going to save? That is a question. So age, I don't have any value, then what I will be saving in that particular position? Any idea?
Null.
Null, sir.
Yes. So we cannot give space. Space is also a value. We cannot provide 0. 0 is also a value, right? So we need to give a value which will identify that this is not a value, right? A value which will indicate that this is not a value. So this is a special character. This is called as null. So as you can see here, null, right? Null values. That means when we have null, that will tell to SQL Server or the user that it is not holding any value. So null itself is not a value, but to identify or to define that it's not having a value, we need to identify with something just to tell that it's not holding any value. So to tell that, we have a special character. This is called as null. Okay. So null represents a missing or unknown value. Okay. So we have some special behavior for null. If we perform 2 plus 2, that will give us 4. But if we perform 2 plus null, it will give us null. But ideally, in general, it should come to our mind like 2 plus null, it should be giving us 2, right? But this is the special phenomenon with that special character null. If we perform any operation with null value, the outcome would be null only. So 2 plus null will give you null. Your string with null will give you null. So any operation with null will give you null. If you want to check null equals to null, it will give you false. Why? Because the equals operator, plus operator, or any operator doesn't work on null values. Okay, so you cannot check null equals to null. To check a value is null or not, there is a special command. This is called as is null. Okay, let me give you an example. Let's say, so select star from, let's say, person.address. Okay, right? So this has gave me some output. Now if I want to do a filtration where I want to see that address line 2 is equals to null, that means I want to see only the details where address line 2 is having null values. Can I do it? So let me put where clause where address line 2 is equals to null. So if I run this, no values, but I can see that there are values in address line 2 holding null, right? So if I'm doing a filtration where address line 2 equals to null, this should give me these rows because it's having null values, right? But any operation with null don't work in normal operator. Okay, as null is a special character, we need to use special commands or special operators to check null values as well. Now to check equals to with null, we need to use is, not equals to. So select star from table name where address line 2 is null. That means it will show only the row where address line 2 is null. So let me execute. So see, only the null values are given. So if I want to see the row details where address line 2 is not holding the null details, then the syntax is address line 2 is not null. Okay, so this is a special type of command. So see, address line 2 is not null. For the output, we can see no address line 2 null value is provided. So this thing we need to understand for the special character null. So we cannot do column equals to null. Instead, we have to do column is null. All right. We cannot do column not equals to null. So by the way, not equals to we check like this. Okay. We cannot do not equals to null. Instead, we need to write column is not null. So this is a special command for the special character. Is it clear to everyone?
Yes.
Yes, sir.
Yes.
This is actually much more easier than Excel formulas, like what I feel.
Yes.
It's just like English.
All right.
Yes.
So it's just the beginning. Don't take it lightly. Anyway,
Arey,
so this is about working with nulls. All right. So that's the end of this slide. Let me go to the class notes. Now, let me go through some more examples of select statements before we go for normalization. Just a moment, guys. All right. Some more examples. Select star from sales order details. So what is go? Go is a separator, optional. Okay. So I can see the sales order details, all the columns as I've given star. Now if I want to see some specific columns, so I need to give the specific column names. Select sales order ID, product ID, unit price from sales order details. So this is the output. In the same way, let's say select name list price from product table. So I have a product table where I have the product name and the list price. There are other columns as well, but I have just selected name and list price. So select name and list price from product table. Now let's say you are running this organization and this is your list price. Okay. Now you want to write a query and get the information of sales price. So this is the list price. That means the costing that is with you, right? To make that product, you actually need to pay that amount of money. Let's say this amount of money. Okay. Let me give a where clause here. Where list price is greater than 0. All right. So now you want to prepare a list where you will be generating the sell price. Okay, sell price means the price which is there for you to sell the product. Now let's say you want to take 1 rupee margin. So to get 1 rupee margin, so this is list price. Let's say you are putting another column, list price plus 1. Okay, so if I run this command, this is the name of the product, this is list price, and this is sell price by adding 1 rupee with list price. So list price plus 1. So this is list price, this is list price plus 1. 147, 148, 196, 197, 133, 134. So how did that happen? That happened because this plus operation on the select statement. Now one thing you guys can note is here the column header is name, here the column header is list price, but here we don't have any column header.
Yes.
Why? Because we have prepared this value. The value doesn't exist in the table. If you open the product table, production.product, right? Production.product. If you open this table, you don't have, so you have list price only, list price, right? So with this, with the help of this column, you have added a value and generated a new output, right? That is why this output is not present in the table. It is only showing you this output based on that existing table data. Existing table data plus 1 is giving you this output. That is why it's not showing you any header, because it doesn't have any column. It doesn't have any physical existence to the table, right? Now for better representation, or to give you a purpose of this column, you can give a name to the column header. One thing to understand, this column doesn't exist physically in the table. It's only appearing in the output of the query. Okay. Now just for your better understanding, you need a header. So let me give you a header here. To give a header, we need to type as, then, so this is my column preparation, right? After the preparation, we need to write as, then column header name. Let's say column header name is sell price. Okay. If I execute the query, see, this is sell price. Same thing with a added header. So
Devabrata, I think
yeah,
your screen is freezed.
my screen
Now
got
I,
freezed. Is it?
yeah,
No,
now it's
that
back.
time
Is my
it was
screen?
No,
freeze.
sir.
I think we are facing server problem or internet problem.
No, I can see like it's
Yeah, yeah,
okay
now it's
from my
fine.
side.
It's,
Yeah.
yeah.
Now
All right.
it's okay.
All right. So is it clear to everyone how we prepared this column and
Yes,
how we have given the column header name? Are we clear with the purpose of this query?
Yes, sir.
yes, yes,
Yes,
clear.
sir.
All right. So let's see a next example. We are filtering with where clause. Select address ID, address line 1, city, postal code from address table where city equals to Paris. So it's showing these column details from address table where city is equals to Paris. We can do the same thing where city not equals to Paris. So not equals to will be written like this. City not equals to Paris. Not equals to can be written in another way as well. This is also not equals to, right? Next is another example of where clause. Another example of where clause. Now this one is an example of checking with null values. Is null and is not null. Right? So all the examples I already shown to you guys, and the example is there with you in the class notes. Okay. Now let's go to the next part, which is called as normalization. Okay. And then we'll go to order by and everything. So order by clause and everything, I don't think I can manage it in this class. Let's discuss about normalization. If we have time, then we can go for order by. All right. Now, what is normalization? Anyone having any idea?
Making it common, kind of.
So it's a technique to design the table. So when I say that please create a table for students, right? So what are the standards? What are the baseline? What are the rules to make sure we are creating a good table structure, right? So there must be some set of rules which will tell us how to create a table, right? So these
Right.
rules are called as normalization rules. Okay. Now the thing is, there are other purposes as well for normalization. The other purposes are to remove redundancy and maintain consistency. Now what? Sorry. Now what is redundancy? Redundancy means duplication of data. And what is consistency? That the truthness of a data. Truthness means if my name is Debu, then it should be Debu throughout the database. It shouldn't be like someone is accessing my name, it's showing Debu, and someone else is accessing my name, it's showing Debu Ghosh. It can't be like this. There cannot be any data discrepancy within a database. That is called as consistency or integrity. Okay, so this is what is consistency, what is integrity. This is a very important topic to understand. I'll put this under homework. What is data and consistency, right? Okay, so normalization is basically a technique to minimize data duplication and increase logical consistency. All right. What are the different type of normalization, or what are the different normal forms? So the different normal forms are 1NF, 2NF, 3NF, BCNF, and 4NF. 1NF is called as first normal form. 2NF is called as second normal form. 3NF is called as third normal form. BCNF is called as Boy's Code normal form. Boy's Code normal form. And 4NF is called as fourth normal form. Okay. So that is about the different type of normal form. In real life scenario, we generally implement till third normal form. Okay. So BCNF and 4NF is basically in theory only. In most of the cases, we don't use BCNF and 4NF. So we implement till 3NF. Okay. All right. So let's understand about what is first normal form. To maintain first normal form for a table, we have 4 rules to maintain. First rule is saying single valued column. That means if I go to a table, let me show you a table. This is my table. Okay. So single valued column. That means each column must hold a single value. See, single value, single value, single value, single value, single value, single value. For every column, you'll be seeing single value only. So it cannot be multiple value. What is multiple value? Let's say ID1, name Suraj, age 28, 29, 30. That is multi-value. City is Delhi, Kolkata, Mumbai. That is multi-value. So any column should not or must not hold multiple values. Every column must be holding single value. Now it may sound very dumb, right? So it may sound like that is very common. It's a common sense, right? But we are not talking about common sense here. We are talking about the basic rules. Okay, so the basic rules must be made, right? So this may occur like, okay, this is very common, right? This is common sense. If we you know, if we apply multiple values, that will make no sense. Age cannot be 28, 29, 30 like this. So let's consider a situation. Let's put under customer, let's put another column, let's say mobile number. So it could happen this customer is having 2 mobile numbers. Let's say one mobile number is 123, another mobile number is 456, right? So the mobile number column can hold 2 values, which is not permissible. Now how we can hold 2 mobile numbers then? Either we need to create 2 columns, mobile 1, mobile 2, or we can insert the same row twice, where one row will be holding all the details with mobile number 1 and the other row will be holding all the details with mobile number 2. But it cannot hold multi-value in a column. Is it clear?
Bhavrata, address also
Yeah.
holds the multi-value.
I mean, it can hold multi-value, but uh, it is not permissible. So
Yeah.
single valued column, right? Now the next rule is same kind of data in each column. Again, it sounds very dumb, but these are the base rules. Same type of data in each column, like ID is holding integer value, name is holding character value, age is holding integer value. It cannot be 1 Suraj 28 Delhi and 2 Aman 26 in string, right? 26 in string, then Patna. Cannot be like this. It has to be numeric. That is applicable for every column. Data type should be the same for every column. That is rule number 2. What is rule number 3? All column name should be unique. So ID, name, age, city, all the column names are unique. It cannot be ID, name, ID, age, city. So then we'll be having 2 ID columns, right? That is not permissible. All the column names must be unique in a table. All right. The fourth rule is row order doesn't matter. That means whatever data you see, the row order doesn't really matter. That means if the sixth row come at the very beginning and the first row come at the very end, there is no change in the data. That means if my table is holding this data, if the data got rearranged to this, that is basically the same thing. So the row rearrangement will not change the data of the table. Is it clear?
Yes.
So is it clear about rule number 4?
Yes, clear.
Yes, sir.
Any questions from these 4 rules?
No, sir.
All right. So one thing I want to tell you guys is, so it may seem like these informations are irrelevant, but these informations may sound irrelevant for learning your programming, but it is relevant when you are designing a table or designing a database. Okay. And more than that, it is a very important question that is basically asked in the interview. Okay. So the simple or very common question is, what is normalization? What are the different type of normalization? Okay. And they will ask you, okay, please explain about first normal form, or let's say please explain about third normal form, right? So that would be the very common questions that you can get in an interview. That is why I'm just covering these topics. Okay. All right. Next is second normal
Devabrata,
form. Yeah.
Devabrata, I have a question. Sorry, I'm interrupting you.
Hmm.
Since you always give important, information in class, is it important to create notes on whatever you are teaching?
Yeah, if
Like
it's
as we,
convenient. I mean, if you feel it, find it convenient to take notes, you can take notes. Anyway, I'm providing you guys notes, right? Apart from this note, if you want to take note, you can take note. If you want to take note after watching the recordings, that is also okay. But I'll recommend to give focus on the class, that what I'm teaching you guys, rather than taking notes. You can take notes later by watching the videos, right? Or I'm providing you a basic set of notes as well, so you can take notes offline. All right. So what is second normal form? Second normal form rule is saying table should follow first normal form. That is rule number 1. That means table must follow these 4 rules and obey first normal form. Then comes the second rule of second normal form. What is the second rule? No partial dependency in a table. What is partial dependency? Partial dependency means, or in other words, there must be a primary key in a table. In simple words. Okay. So there must be an ID column or any primary key column using which we can uniquely identify a row.
So
Is it
basically
clear
a
to
unique
everyone?
ID, a unique ID for each row, right?
Yes. Yes. So there
Oh,
must be a unique column using
okay.
which we can uniquely identify a row. So what is the unique
sorry,
column here in the table? Yeah.
Devabrata, I lost my connection altogether. I haven't, heard what you said. I mean, what was your answer actually? Can you please repeat once?
Yeah. So let me iterate the
Regard,
line. Rule 2 is
regarding notes.
rule 2 is oh, note you can take
Yeah.
it offline. Note you can take it offline. Okay.
Okay.
All right. So rule number 2 is saying no partial dependency in a table. So in other words, there must be a column using which we can uniquely determine a row from the table. So in this table, what is the unique column using which you can uniquely identify a row?
ID.
I
ID.
Right. ID column is the unique column. So this column will be called as primary key. Okay. So primary key is the unique column using which we can quickly
Primary key.
identify a row from the table. Right? That is, where was I? Yeah, that is rule 2 of second normal form. Now, when I can say that a table is in second normal form, if it maintain first normal form as well as it maintain this rule, right? Then only I can say the table is in second normal form. Now, let's talk about third normal form. What is third normal form? The same way, the table should follow second normal form and no transitive dependency in the table. Now, what is transitive dependency? That is a tough thing to explain. So, transitive dependency. Let me first give you a table structure. Let's say address. Okay. In address, I have ID, which is the primary key. I have state. No, not state. Let's see the address table here. Address line 1. Address line 1. Address line 2. Okay. Pin, state, city, district. So this is my address table. What is the primary key in this table?
That's the
ID.
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 Is the primary key. Now, if we know the value of ID, can we determine rest of the columns uniquely?
Yeah.
Yes.
Yes.
We can do this, right? So as we can uniquely determine these things, so I can say if I know the value of ID, I can know the value of pin. Guys, please go on mute. There are some background noise. So if I know the value of ID, I can determine all the other columns, right? So I can say if I know the value of ID, I can know the value of pin as well. Yes or no?
Yes.
All right. Now, if I know the value of pin, I can automatically determine the value of this. If I know the value of pin, I know what state it is, what city it is, what district it is. So pin can determine state, city, and district as well. Yes or no?
Yes, sir.
Yes.
Yes.
Yes, sir.
So logically
Yes,
it
sir.
can determine, right?
Hmm.
So,
Yes, sir.
so understand this very carefully. ID can determine pin, pin can determine state, city, and district, At the same time, ID can also determine in city and district, right? Because ID is a primary key. If I know the value of ID, I can know the value of everything, right? So if I know the value of ID,
Yes, sir.
I can know the value of state, city, and district as well. So this type of
Yes, sir.
relation is called as transitive dependency.
Can we have an
What
example of
is,
this?
yeah, this is the example only. Okay. So what is transitive dependency is saying is if A determines B and B determines C, then using transitive dependency, A can determine C. A determines B, B determines C, so A determines C.
See.
Is it clear?
Yes,
Is
sir.
it clear to everyone?
Yes,
Yes,
sir.
yes,
Yes, sir.
yes.
Now this is called as transitive dependency. Now third normal form is saying no transitive dependency in the table. So we not should we must not have transitive dependency in a table. So this table is not in third normal form because in this table we have a transitive dependency. Now we need to remove transitive dependency from the table. How we can do that?
Remove
We can
in
do that by dividing the table into two parts.
two.
First would be address, second would be area code. So address table will be holding these details and area code will be holding these details. So address table and area code table is now related to each other and the relation is created using pin column, right? So this table does not have any transitive dependency. This table also does not have any transitive dependency. How we avoided that? We removed the related column or we splitted the table in such a way that the related columns are getting splitted into two other tables so that we can avoid the transitive dependency. Now the question is, what are the benefits of removing transitive dependency, right? So let me
You
give
can
you
read
the
the question.
example. So it will eliminate data duplication. Let's say ID is 1, address line 1 is ABC, address line 2 is CDE, right? Pin is 100. State is, let's say, West Bengal. City is, let's say, Kolkata. District is Jadavpur, right? So whoever lives in this under this pin, all right? Whoever lives under this pin for all the row, this particular thing would be same. Whoever lives in Jadavpur area in West Bengal, Kolkata, for them this part would be repetitive. Yes or no?
Yes, sir.
So if I store the next row, okay, so let's say address GHF, address line 2 is OKJ, okay. Now he or she is also living under the same pin. So this is the same applies for the third row, let's say, all right, and the same, it could happen, right? It could very much happen. So we can see a data repetition or data duplication, right? Now if we split it into two, so the actual data we want to save is this, right? But along with that we are saving the duplicate data in the table as well, right? Now if we split the data into two, what will happen? This table will hold only one row, right? And this table will hold all the distinct rows. And here we are going to refer the pin address. So here what we are doing is we are removing the data duplication from the table, and instead of repeating the data here, we are just keeping the data for once in area code table. And how we are relating these two data? Using the pin column from this table to this table. Is it clear to everyone?
Yes,
Yes.
Saurabh here. Question there with this one.
Yeah.
Uh, the normalization part of the table, the data, right? Like,
Mm-hmm.
is
Mm-hmm.
it done from the machine level, like from the system level, or we do it manually in the while creating the tables?
We do it manually when we design, not creating a table, when we design a table. So this is
Okay,
basically during the design part.
okay, okay. Got it, got it. Mm.
So how well you manage the structure, how well you use the normalization form will define how well the table structure is created, and that will define how much you can reduce the data duplication. Okay, so let's say you have designed a database like this and your friend has designed a database like this. So obviously this is a efficient way, right? If this database size is, let's say, 10 GB, having a table structure like this will automatically increase the database size to 15 GB, because this database is holding repetitive data in the database, right? Where this database is not holding the repetitive data.
Yes,
Is it
yes,
clear?
correct.
Anyone having
Yes,
any
sir.
questions? Hello. So today, so I want to wrap it till here, because that would be a logical ending for today. So let's see what we have learned today. So we learned about the introduction of SQL programming language, right? Different type of commands, different data types, ACID properties. What is ACID property? That is something I want you guys to do homework. That is not a very easy thing to understand. Please do homework or try to learn about ACID property. Tomorrow, the first thing we'll start with is ACID property. Okay.
Okay.
Mm, So we learned how we can put comment lines, right, in the coding. What is comment line? These are the comment lines, right? Starting with double dashed. Now we have learned about how to perform select command, how to perform, arithmetic operation within select command. We learned about where clause, not equals to commands. We learned about the special character null and the special operator to use null character. And then we learned about normalization and different type of normalization with practical examples. So this is the homework. Seems like only two topics, but these two topics are a bit tricky and confusing. If you paste the homework in the chat, guys, please take the homework notes from the chat. Okay, and I'll be providing the class notes to Sanchita. She'll be passing it to you guys. So, any questions before we wrap up for today?
No, sir.
All good? All right. Thanks, everyone. We'll be catching up tomorrow. Good night.
Thanks.
Good
Goodbye.
night.